Hey guys, let's take a look at one of the homework problems from section 3.2. This problem is a quotient, so we'll use a quotient rule on it. We need to do a little bit of altering first in order to be able to take the derivative a little easier. So we'll change the square root of x into x to the 1/2 power. And now we can go ahead and take our derivative. Remember that quotient rule is low times derivative of high minus high times the derivative of low over the low squared. Alright, so f prime of x is going to be low times the derivative of high. So we need the derivative of this right here, and that's going to be 1/2 x to the negative 1/2. Then we do minus high, x to the 1/2 plus 1 times the derivative of the denominator, which is going to be 2x. And all of that goes over the denominator squared. Now, if you're doing WebAssign should take that. I don't think you have to do any kind of simplifying at all. As long as the derivative's right, you should be good, okay? Now, for me, on our test, I want you to go just a little bit farther. So what I want you to do is go ahead and multiply out the things that are in the numerator. The main reason why I want to do this is because I want to see if there is anything that I can cancel. There may not be, and that's fine, but let's just kind of see how the numerator is going to lay out. Alright, if I distribute the 1/2 x to the negative 1/2, remember, when you combine by multiplying, you have to add your exponents. So that's going to become 1/2 x to the 2 minus 1/2, which is 3/2 power. And then just 1/2 x to the negative 1/2 when I multiply it times 1. In our second group, we're multiplying times a negative 2x. Both of these are going to be distributed through this. So it's going to be negative 2, and then I'm multiplying again, so I add 1/2 and 1, because the exponent here is a 1. So that's going to give me x to the 3/2 again. That gives me two common terms there that I can combine. Then do negative 2x times 1, and we have our numerator multiplied out. Now what I want you to do, in addition to multiplying it, is go ahead and combine like terms if you can. So I've got two like terms, this one and this one. We need to combine those two by adding the 1/2 and the minus 2 right there. So that's going to give us negative 3/2 x to the 3/2 plus 1/2 x to the negative 1/2 minus 2x over x squared plus 1 squared. Now, I'm actually okay with that, okay? If you have multiplied out your numerator, if you have combined like terms like we did in that next step, then I'm okay like this, okay? You can leave it in this form for the test. But now keep in mind where we're heading, okay? We will be using these derivatives to do other stuff with. So let me go ahead and show you what you would need to do next if you're planning on being able to set this equal to 0 and solve for x, that kind of thing, okay? So this goes a little farther into the simplification. The main problem here is that we have fractions in the numerator. Not only do we have numerical fractions, 3/2 and 1/2, we also have the x to the negative 1/2, which would be a fraction if I wrote that without the negative exponent. I can take care of those two things pretty easily by factoring them out. Now keep in mind, we're kind of used to, when we hear the word factoring something out, we're used to associating that with a greatest common factor, okay? Well, even if the particular factor you're moving out is not a common factor, you may still be able to take it out. Factoring is like division. So if I want to take out a 1/2 to get rid of those denominators, I just simply divide each one of the terms in the numerator by 1/2. It's the same thing as multiplying by 2. If I want to get rid of the negative exponent, I can factor out the x to the negative 1/2, and there again, it's just like I'm dividing each term by the x to the negative 1/2. So let's see what that does for us. If I take out a 1/2 and an x to the negative 1/2, When you factor out the x, the common x, always take the one that has the smallest exponent out. That way you can get it factored out completely. Let's see what that leaves behind. On the first term, we're doing negative 3/2 divided by 1/2, which is the same thing as multiplying 3/2 by 2. So that gives you a negative 3. And then when you when you divide the x to the 3/2 and x to the negative 1/2, you subtract the exponents. So 3/2 minus a negative 1/2 gives me x to the 4/2 or x squared. In the second term, taking out the 1/2 leaves you with a 1, and then taking out the x to the negative 1/2 leaves you with a 1, so that just becomes a 1. In our last term there, if I divide 2 by 1/2, it's the same thing as multiplying 2 by 2. And then if I divide x by x to the negative 1/2, I get x to the 1 minus 1/2, which is 3/2. Okay? I know that's a little tricky to begin with because we're not used to thinking about factoring when we've got fraction exponents, negative exponents, and all of that, but you get used to it as you work more and more of these. This is still in the bottom, and then I also need to bring down the 2 from the 1/2, pull it to the bottom, and then the x to the negative 1/2 can be put on the bottom. We just need to take the negative off the exponent. That's going to be multiplied by what's already down there, and then we leave 3x squared. I'm going to go ahead and pull this term next to put it in descending order, plus 1. So that's the final result if you're trying to, say, set this equal to 0, solve for x, use it in some other way.